We'll start with the embedded C, okay, and then we'll move to the embedded concepts, ARM processor, STM32, okay. Here, what is embedded C? How it is different from the normal C? The main concept is most of the people thinks both embedded C and normal C are different languages, but here both embedded C and the normal C is both are same, okay. If both are same, then why we are calling it as a different languages? Means the only thing, if you use normal C language for general purpose application development or general purpose things, then you call that particular C language as normal C language. If you use same C syntax, same C keywords, same C for developing something in embedded systems, then you call that particular C as embedded C. And not only that thing, there are some differences in case of using, not in the way of syntax. Every syntax and the structure are more or less same, but the how to use, the usage is different. If you use the C language for writing normal programs, then you call that as a normal C. If you use same C language for writing the code in embedded or code for any embedded device, then you call that is an embedded C. Clear? There is no much difference. Now I will tell you what are the differences also. See here, first, what is C language? C is a general purpose programming language. It was actually developed by Dennis Ridgely at 1972 at Bell Laboratories. It's all we know about this one. And here C is a high level language. What is the meaning of high level language? High level language means if a programming language is human understandable language, then we call that as high level language. Okay. If the same programming language is mission understandable language, which means zeros and ones. We all know mission can understand only binary language, that is zeros and ones. So if we write a code only in zeros and ones, then you call that type of code as low level code, okay. But C language is not a low level one, it is a high level one. And some people says C is a middle level language. Why it is middle level language means, by using C language you can achieve both high level language features and as well as low level language features. How means, by using C you can develop applications, you can use it with normal software, normal programs, okay. In the same way, by using C you can write low level register configurations also in embedded boards. So it is used for both high level programming and low level programming. So somebody may call it as a middle level language also. That's also true. If you want, you can call it as a high level language or middle level language. And one more thing, it is known for its speed, efficiency and close to hardware programming capabilities. Now, one more question is, why we are using C in embedded systems? More than 90% of embedded development is in C. Even though there is assembly language, even though there is binary language, even though there are many languages in the market, still we are using more than 90% C. Why means, there are actually three reasons. Whenever you are developing an embedded system, you should consider three things. First thing is speed. Second thing is power consumption. Okay. This and the next one is efficiency. Always your embedded system should be speed enough, because if you develop an embedded system, it is responding after 2 or 3 minutes, that's not a good in real time, right? So it should be speed. And one more thing, it should be power efficient. Means for embedded system there is no big batteries like your laptop or mobile. It is having very less battery, or the input power also very less, around 3.3 volts or 5 volts. So your embedded system should consume less power and it should be efficient, okay. And one of the reason for selecting C is it is a speed, efficient, and one more reason, and most important reason is it is very close to hardware programming capabilities. Why it is very close to hardware programming capabilities means, here see, in hardware, for every hardware module, for every peripheral, there is a address, physical address. Suppose, let me give you one example. Do you know GPIO ports, general purpose input output ports? Suppose if you want to do any configurations in that port, then what you have to do? For every port, there is specific registers are there, some registers. You have to write some configurations in that registers. Now, if you want to access that particular registers, how to access? The answer is by using the address of that register. For every register, for every hardware module, there is a specific address in hardware. So, your programming language should support the addressing things. It should support the storing of address, like that kind of things. In our C language, we have one concept called pointers. I will tell you in the next class. Okay. By using pointers concept, you can access any address. So, by using address, you can write anything in the hardware. So, here the thing is, it is very close to hardware programming capabilities because of pointers. The next one is, C is the foundation of many modern languages. We know already C++, Java, and Python. And it is widely used in system programming, embedded systems, operating systems, and device drivers. Mostly in system programming or in embedded systems, operating systems like FreeRTOS, VxWorks, Linux, and the device drivers. We will discuss about device drivers also in this course. Okay. So the reason why we are using C language in embedded system, first one is we already discussed it, very close to hardware capabilities. That is direct access to memory and registers using pointers. Using pointers concept, you can directly access registers and memory. By accessing it, you can configure however you want. The next thing is fast and efficient. The minimal runtime overhead and high execution speed. One more thing, your embedded system should be fast. So you have to use the fast executing programming language, that is C. The next one is portable code. You know the meaning of portable code? Portability means even though your code should work in different platforms also. But here remember, C is a portable one, because if I write one code in my laptop of HP laptop Intel i5, if I share the same code to you, even your laptop is of different configuration also, you can run that code, right? So C is a portable. But remember one thing, embedded C is not a completely portable one, because normal C can run on any platform, can run on any hardware like Intel or any other processor, any laptop. But embedded C is specifically designed for that particular microcontroller or particular microprocessor. If suppose, let me give you an example. I have STM32 F407 board. I wrote one big code for the driver. Now I have the same different chip in the same STM32 family, maybe STM32 nuclear board. Both are STM32 only, but hardware wise some changes are there. Now I wrote one code for STM32 F407. That same code will not work in the other microcontrollers, because hardware wise there are some changes. So the functionality is same, but due to some changes, while running in another platforms, you have to consider that thing, you have to change some things. See here, now I will tell you the difference between C and embedded C clearly. Okay. See, the first one, what is the purpose of normal C programming? For writing simple general purpose programming, developing general purpose applications. Okay. But the purpose of embedded C is programming embedded systems. We use for programming embedded systems. And here see, target environment. Target environment means where you run this code. After writing the code, where you run. In general, the C programs we run on computers, desktops, laptops, right? The OS. But the embedded C we run on that specific microcontrollers, that specific IoT device and embedded systems. And one more thing, if one embedded code is developed for one particular microcontroller, we will run that code on that particular microcontroller only. Yeah. And standard libraries. Do you have any basic idea of standard libraries like stdio.h, stdlib.h in C? General, C has this kind of standard libraries. But mostly in embedded development, we only create our customized header files. Okay. Because one chip may different from another chip. That's why as an embedded developer, you have to create your own header file for your chip. I will tell you that things also in future class. Memory management. Here there is one concept in C that is called dynamic memory allocation. We'll discuss in the later classes. In normal C, we use the dynamic memory allocation also, but in embedded C, we mostly don't use the dynamic memory allocation. We use, but mostly we don't prefer, because in embedded system the memory is limited. Suppose if you consider your laptop, the internal storage may be 512 GB or 1 TB, even more is available. But if you consider any embedded system or any microcontroller, the RAM and ROM are only in kilobytes, 120 kilobytes, 200 kilobytes. So the memory is limited. That's why if you use the dynamic memory allocation concept, then you may come up with some memory related issues, because it will consume more memory. Okay. The next one is hardware interaction. The minimal direct hardware interaction, and here the direct interaction with the hardware registers. In normal C, we no need to interact with the hardware. What is the need? But in the case of embedded C, we have to interact directly. Next, to real-time constraints. No real-time constraints, requires precise timing and real-time constraints. Real-time constraints means, suppose you are using your laptop. Okay, you opened a Chrome browser. Can you tell me how much time it takes to open? We can't tell the exact time for all the laptops. Maybe in your laptop also, if suppose many applications are running at the back end, then it takes 4 or 5 seconds. If no application is running, your processor is efficient or good, fast one, then it can open within second. So there is no such kind of the deadline. It should open within the 1 second. It should open within 2 seconds, right? So even though sometimes it takes 2 or 3 seconds more, that will not cause much impact. The much effect. That is a real-time constraint. Here there is no real-time constraints, but when it comes to the embedded systems, there are real-time constraints. Real-time constraints means, here I will tell you the example. In car, the airbag control system. Whenever the car meets with an accident, within microseconds, not second also, within microseconds, the airbag should open, and that microseconds also already predefined. The manufacturer, whoever manufactured that airbag control system, he defined the time as, let it be 5 milliseconds or 5 microseconds. So within that 5 milliseconds or 5 microseconds, the airbag should open. If it delayed by few milliseconds also, anything may happen, right? So these are some kind of real-time constraints. And one more thing, all embedded systems are not real-time not have real-time constraints. Why means, if you consider your washing machine or ATM machine, these are also embedded systems. But can you tell me, if you enter any, if you try to withdraw money from ATM, it will give within 1 second or within 2 seconds? No. So that's not that is also embedded system, but there is no such kind of real-time constraint. Yeah. So based on this time constraint, we divide actually the embedded systems as 2 types. First one is hard real-time system. Wait. I will explain you these things in the last video, but for now remember hard real-time systems. Next one is soft real-time systems. Both are embedded systems only. But here thing is hard means here you already define the time. Within the time, it should run the code. It should do the corresponding task what we assign to it. If even it takes 1 microsecond more also, we consider that system as a failure system. Now soft real-time system means sometimes it may take 1 or 2 seconds more. That will not affect more. Okay. Next one is portability. Here it is highly portable across platforms. You know, normal C program, it will not depend on the hardware. That's why it will run on any laptop, any computer. But here see the limited portability due to hardware dependency. Actually the embedded C depends on hardware. That's why the portability is less. Here the compilation and execution. Actually there are some compilers we use for writing embedded C and normal C. Mostly for normal C we use GCC, CLang. For embedded C we use Keel, AVR, and based on embedded microcontroller also, the microcontroller manufacturer gives some compilers. In our course we use STM32, right? The STM32 manufacturer itself give one compiler to us. We use that thing. Okay. I will tell you what is compiler, everything. Don't worry.